the difference of squares as a factoring strategy. So like usual, we're going to talk about it as a strategy and then also how to solve it a couple of different ways. So previous factoring strategies include finding the greatest common factor and factoring trinomials, including a perfect square trinomial. So as we keep those things in mind, let's look at this vocabulary first. Difference of squares. Difference means we would be subtracting, okay? And sometimes I would say this is a difference of two squares. So you have to have a perfect square here, subtract a perfect square here. If that's what you have, this is great. So if we wanted to think about it as a trinomial, we would have had this example as k squared minus 100. And if we had a trinomial, there's like 0 k's in here. So the question we would ask ourselves is what multiplies to be 100 and adds up to be a 0, negative 100, and it adds up to be a 0. So if we were to really investigate this fully, we would figure out that it would have to be this 10 and 10. So we would be left with factors of k plus 10 and a k minus 10. Okay? But because it's a difference of squares, it's just as easy. One of those special products we've had in the past, where if you notice there's just 2 of them and they're perfect squares and it's a difference, it's what is this a perfect square of? What is this a perfect square of? One of the factors is plus, one of the factors is minus. So it's 2 different ways to look about this strategy, difference of squares. Keeping in mind we do always want to look for a GCF first if we can. So this next example says 144 minus 9f squared. So it's not in descending order, but that's okay on this one. What we would notice, this is a perfect square of 12, and this is a perfect square of 3f. However, we forgot to take out the GCF. The GCF is in fact a 9. So we would have 9 times 16, and if I took that divided by 9, just get an f squared. So this is our reduced answer. 16 is a perfect square of 4. That's a perfect square of f. So we should have 9 times a 4 plus f and a 4 minus f. Okay. The reason I didn't switch those around at all is because I like to keep my beginning of my polynomial as a positive number, usually. So that would be why I didn't do that. Okay, let's look at this next couple here. And maybe you can try them, pause it, and then put the answer up. There is no GCF. They are a difference of perfect squares. So we're good to go. It would just be 6g plus 7h and a 6g minus 7h. On this one, we do have a GCF. The GCF is, in fact, a 3t squared, which leaves us with a t squared minus 16. And those are, in fact, the difference of squares. So 3t squared, t plus 4, t minus 4. So this is my most favorite factoring strategy ever. Okay, so if we're looking at these, this one is an example of a non-example. So this is a perfect square of 3D. This is not a perfect square. So at the beginning of your assignment, you would just write prime on this one. Okay, reason being right there. This one has a GCF, so as it is right now, it looks like we don't have any perfect squares. If I take out a 5q, what we're left with is a 9q squared. That's a perfect square, minus 4, which is. So again, always look for that GCF first. 3q plus 2 and 3q minus 2. And by now, you may have fast forwarded a little bit. So our typical solve strategies that we've had in the past include that we always want to set it equal to 0 in descending order, right? Then we always want to factor it completely. And then we set each factor equal to 0. Okay? The other strategy that we had, and we already talked about a little bit, is called the square root method. Okay, so let's talk about both of these strategies here within these 2 examples. So if I were to factor this first one, those are difference of perfect squares. That is a 6x and a 5. It was already set equal to 0. It was already in descending order. So then, according to our normal strategies, we would say either the 6x plus 5 must equal 0, subtract the 5, divide by 6, or the 6x minus 5 would have to equal 0. So we would add the 5 and divide by 6. And those would be our two answers. Okay? On this one, if I chose, so I noticed for the next one, the way it started out, it's already not equal to 0, but I only have one variable term. So what I could do, possibly, is I could get the squared term all by itself. So I could divide everything by the 4. And then I could, to get rid of a square, we're going to square root. So I could square root that. But anytime we square root a number, it's going to be plus or minus the square root. And the square root of 81 is really just a 9, and the square root of 4 is really just a 2. So our answer is just positive or negative. When it comes to solving, you can do whichever way you wish. Keep that in mind. In the end, this was going to be a positive or a negative 4/7, one way or the other. Okay, so this right here was the square root method on that second example. This is the way we've been doing it forever, which still applies and still works wonderfully. It's really up to you, but this was meant to be a quick lesson with a lot of examples on the difference of squares.